Welcome back to the course of chemical crystallography. Today we will have a tutorial on the topics that was discussed in last few lectures. This is based on the assignment that was given to you on third week. So this is the discussion on the problems that was given in the assignment in week 3. So the first problem that you can see here, it is asking you to draw the stereographic projection of P21 by C and C2 by M and to find the equivalent points. I hope you understood how to do this, and we will try to work it out quickly for these two space groups. So let us first start with P21 by C. So what is this? This is a space group in monoclinic system, right? And it is a primitive lattice. It has a symmetry 2, 1 parallel to Y and a C glide perpendicular to Y. So if we just try to get the equivalent points by starting from x, y, z, if we simply apply a 2, 1 screw parallel to y, we should get x bar y plus half z bar. We apply the C glide perpendicular to y on x, y, z. What we get is x, y bar, z plus half. So now if we apply 2, 1 parallel to y on this point number 3, if we number them as 1, 2, 3 and the fourth point that we get is nothing but x bar y bar plus half z bar plus half. Remember that when we are doing 2, 1 parallel to y, it is x is becoming minus, y we are adding half because the translation is along y, and z bar, here it should have been minus z minus half. We convert that minus half to plus half by adding 1 unit along z. So that has already been incorporated here. So now what is the relationship between the point 2 and 4? This is again C glide perpendicular to y. So now if we look at the points 1 and 4, they are related by an inversion center I, but I is not at origin. That is, it's not at 0, 0, 0. So this I not being at origin indicates that the origin has to be shifted at some point. Where should we shift the origin? We need to look at these 2 points and see that there is a component of half translation along y and z which prevents these 2 points from becoming inversion related at origin. So we shift the origin to a new point 0, 1/4, 1/4, and then we should recalculate the new for the points 2, 3 and 4. How this translate transformation has to be done, I have shown it in the class for 2, 1 by M space group. So, you do it yourself in the same manner, and if you do it right, what you would get are the points which are like this. The first point is always x, y, z. Point number 2 is x bar, y plus half, z bar plus half. Point number 3 as x, y bar plus half, z plus half, and the fourth point is x bar, y bar, z bar. Now the stereographic projection, that means how these symmetry elements are represented in a two-dimensional pattern, is the stereographic projection, and we have discussed this in the class, so I am not going to elaborate it here. There are different sources where you can get these images and check your answers. In case you have any difficulty, you can write back to me. Now let us see what happens when it is a different space group C2 by M. So when we have a space group like this, it means it is a monoclinic C-lattice which immediately indicates that you should have points x, y, z and x plus half, y plus half and z as equivalent points because of C centering. So what we should now do is apply the symmetries on both x, y, z. So we apply 2 parallel to y, you should get x bar, y, z bar. We apply M perpendicular to y, we get x, y bar, z. You again apply 2 parallel to y, you would get x bar, y bar, z bar, and then if we try to relate, it is again mirror perpendicular to y. So here we get 4 points from the original point x, y, z. The relationship between point number 1 and 4 is I. Relationship between 2 and 3 is also I. So there is no need for origin shift in this case. The inversion center coincides with the origin. Now we start with this fourth point, which is fifth point, which is x plus half, y plus half, z. We do a twofold parallel to y, we should get x bar plus half, y plus half, z bar. If we do a mirror perpendicular to y on point number 5, we get point number, this is point 6, this is point number 7, which we get as x plus half, y bar plus half, z. Remember again here, when we are doing mirror perpendicular to y, This means it is becoming minus y minus half. We are adding 1 along y to make it y bar plus half and z. Then we apply again 2 parallel to y. You should get x bar plus half, y bar plus half, z bar. So now this 7 and 8, 6 and 8 are related by mirror perpendicular to y. So once again we see that the points 5 and 6 are inversion related. Similarly 5 and 8 are inversion related, 6 and 7 are inversion related, and we do not need to do any origin shift. For the stereographic projection, once again I want you to look at the textbook and get the drawing done clear yourself. So the next problem which we had here in this assignment, the question number 2. Here you are supposed to draw a few HKL planes with given designations inside a cube. So the first one is 110 plane. So first we should draw a cube. And what we note here, when it is 110, the plane is 110. That means the intercepts should be 1, 1, infinity, which means this plane is parallel to z. So if we assume x in this direction, y here and z up, the intercept on x is 1, intercept on y is 1, so this means the plane is like this. So this is the 110 plane in the unit cell. The next one is 202. Once again we should draw a cube. And then try to find out the intercepts. So the plane is 202, which means the intercepts should be half, infinity, half. So when we have infinity as intercept in in K, it means that the plane is parallel to Y. So now if we start at origin, the x-intercept is half, z-intercept is half. So the x-intercept half means the plane should be something like this. Is that clear? The next plane that I want to draw is the 321. The 321 plane inside the lattice is going to be little difficult to imagine. When we say 321, the intercepts are 1/3, half, 1. So, if we assume this direction as x, y and z as before, the intercept on x-axis is 1/3, somewhere here. Intercept on y-axis is half, so the intercept is here, and intercept on z-axis is 1, so it meets there. So the plane is like that. Now I want to draw this 1, 1, 1 plane in this same cube. So this is not 1, 1, 1, this is 1 bar, 1 bar, 1 bar. So this 1 bar, 1 bar, 1 bar plane indicates that all the intercepts are negative. So if we consider the original origin as origin, then it will not be possible to draw inside the cube. So to draw it inside the cube, we need to choose a new origin such that all the intercepts will be negative. So to do that, we choose the other diagonally opposite point as the origin and make it x, y and z in this direction. So now the intercepts are going to be if the plane is 1 bar, 1 bar, 1 bar, the intercepts are going to be -1, -1, -1. So with respect to this new origin, the -1 along x is there, -1 along y is here, and -1 along z is at that point. So we are talking about a plane which is this one. Right? So I leave it to you to draw the other two planes. The next point where we have the question is you have to identify the Miller indices of some of these planes. So let us see the first one. Here the first one, as you could see, is parallel to both x and y because it is having x and y parallel. So intercepts along x and y are infinity and infinity, and it cuts z at 1. So you take the reciprocal 0, 0, 1 and then enclose it in the first bracket. So this plane is 0, 0, 1 plane. Now you see we have given another plane. This particular drawing is not very clear, but what I want to show here is that we mean to get the Miller indices of this plane. So what it means that this plane is passing through the origin O. So once a plane is passing through origin O, we must shift the origin to a desired suitable position. So if we now shift the origin to this point and consider the plus direction of x here, y and z. So now we can see that this particular plane is parallel to my x-axis. So the intercept along x is infinity. This plane meets y at half and it meets z at -1. So if we take the reciprocal of that, it becomes 0, 2, -1. So this particular plane, the Miller indices would be 0, 2, 1 bar. Now if we look at this particular plane, what we see here is that the intercepts that are given are both given along z. This one is half along z, this is 1/3 along z, which means that the particular line which is coming from z equal to 1 like this has to go and meet y at some point, and similarly the other line which comes like this has to come and meet x at some point. So what we see that the line from here to there travels 1 unit along the lattice or along x, but it travels half along z in negative direction. So this point, this line would meet x-axis at 2. Similarly, this line has travelled 1 unit along y while it has come down by 2/3 along z. So to get down by another 1/3, it would go and touch here at 3/2. So the x-intercept is 2, y-intercept is 3/2 and z-intercept is 1. So you take the reciprocal, half, 2/3, 1, clear the fractions, 3, 4, 6, and this is the Miller indices of that particular plane which is drawn here. The next plane which is given looks like that. Once again, what you should notice is that if we consider origin at the given point, it becomes difficult to visualize the intercepts. So we should shift the origin to a convenient location. We can shift the origin to this point and consider this direction as x, y and z. So now with respect to the new origin, this plane is parallel to x, so the x-intercept is infinity. It meets y at -half and it meets z at -half again. So by taking the reciprocal, we get 0, -2, -2. So this is the plane having indices 0, 2 bar, 2 bar. Okay? The next plane which is there is also required that we shift the origin to a new place, because with this origin which is marked in the figure, it is difficult to visualize the intercepts. we shift the origin to a new position here and consider this as x, y and z. So, now with this new origin, we see that this plane meets the x axis at 2/3, y axis it meets at minus 2/3, because this 1/3 is measured from the old origin. So, this is 1/3. So, the remaining portion that side is 2/3. So, it is from that origin it is minus 2/3, and it is parallel to z as we can see. So, the z intercept is infinity. So, we take the reciprocal. So, 3/2 minus 3/2 0. So, we now clear the fraction and write it as 3 bar 0. So, the Miller indices for that is 3 bar 0. So, today we have discussed about the Miller indices, how to draw the planes inside a cube, or when a cube is drawn, how to determine the Miller indices of a plane. So, in the next class we will continue discussing these, and then in the following tutorial we will solve some more problems.